Yeah, welcome back, everybody. Today we're taking a new topic, and that the date is 18, and that is 18th of June 20. Yeah, the topic we are taking today is cylinders and cones. We are looking at cones. We are going to be talking about surface areas of cones and cylinders. Now let's see. You remember you all know what a cylinder looks like. Let's start with a cylinder. This is what a cylinder looks like. The 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 the, the container in which your beverages come, the containers in which your beverages come are mostly cylindrical in shape. Now this is a cylinder. It's a circular prism. Now it has two circular faces and a round body. Now this is its height. This is the height of a cylinder. Let's call that h. And this is the base radius. The radius of that circular base. This is the radius. The radius of the circular end, each of the circular faces is usually denoted r. Now the volume of a cylinder is given by the formula pi r squared h. That agrees with the definition of the volume of a prism, which is area of cross section times height. The cross section here is a circle and its area is pi r squared and the height is h. Now total surface area, we're just going to list those formulae quickly and then solve questions on them. So that's total surface area. Total surface area. The total surface area of the cylinder is given by the sum of the areas of the two circular faces plus the curved surface area, which is 2 pi r h. And this can be reduced to 2 pi r into r plus h. And the curved surface area is given by the formula 2 pi r h. Now it's important to note what the net of a cylinder is. The net of a cylinder means, by the net of a cylinder, I mean the shape that is folded, into a cylinder, or the shape that you have when you open up a cylinder completely. The net of a cylinder is actually a rectangle and two circles. So that means a cylinder is actually made from this. That's a rectangle and two circles. And that's it. That's the net of a cylinder. The net of a cylinder is made of... The net of a cylinder has a rectangle and two circles. Is made of, has a rectangle and two circles in it. Now let's go to a few examples on problems involving volume and surface areas of a cylinder. Now let's say that calculate the total surface area. Calculate the total surface area. Total surface area of each of total surface area of each of the closed of each of a closed cylinder of each of the closed cylinders below, and these are the cylinders. We take the first one. It's a small one like that, and here the radius is 7 centimeters. The radius is 7 centimeters. I think I want to just put the radius outside here. The radius of a cylinder is 7 centimeters, and its length or height, when it slips this way, you can call the height, you can call it a length instead of a height. But when it stands, you call it a height. So when you hear length, it's still the same as, is actually the same as height. Now this is the second one. Here the diameter of this circular end is 14 centimeters. So of course you know what the radius will be, which is 7 centimeters. And the height of the cylinder, you can see here the cylinder is standing upright, is 10 centimeters. We go to another one, C. It's a similar one to, this is a similar one to B. We have that and this. This is 10 centimeters. The radius is 10 centimeters. And so height is also 10 centimeters. And to the last one, D. This is a cylinder. And this is a circular end. Now here, the diameter of that circular face is 2 centimeters here, while the length of the cylinder, or if you like height, is 3 centimeters. Now we go to a solution. We are finding the total surface area, don't forget. I don't need to redraw the diagram. I'm just going to copy it and paste it here. And paste it here. So that's that's the diagram. Now, how do we find the total surface area? Total surface area equals 2 pi r into r plus h. Of course, that's from 2 pi r squared plus 2 pi r h. Let me write that first before the simplified form. 2 pi r squared plus 2 pi r h, which is 2 pi r into r plus h. And that simply means take pi to be 22 over 7. Pi equals 22 over 7. Take pi equals 22 over 7. So that's the value you'll be using for pi. And that means 2 times 22 over 7. 2 times 22 over 7 times the radius here is 7 times radius, which is 7, plus the length, which is the same as the height, 7 plus 20. And that means 7 here 1, 7 here 1, and then you have 2 times 20, 22 is 44 times 7 plus 20 is 27, and that's equal to 1,288 centimeters squared. That's the total surface area of that cylinder. Now to B, we're copying that 2 and pasting where we need it. Yeah, that's B. This is B. And then how do we go to the total surface area? Total surface area. Total surface area equals 2 pi r into r plus h. And that's 2 times 22 over 7 times the radius here is 14 over 2, which is 7, into bracket 7 plus height is 10. And that means 7 here 1, 7 here 1, and then we have 44 times 44 times 17. 7 plus 10 is 17. And that's the same as 748 centimeters squared. Now to C. Let's bring that down. That's question C. Total surface area. Total surface area. Total surface area. Total surface area equals 2 pi r. 2 pi r into r plus h. Into r plus h, which is 2 times 22 over 7 times r in this case is 10 into bracket 10 plus 10. H is also 10. And that's 44 times. That's 44. That's 440 over 7 times 20. Of course, 2 times 22 is 44 times 10 is 440 over 7, and then 10 plus 10 is 20. So that means that's 12,1257.143, which is approximately 1257.143, which is approximately 1257.14 centimeters squared. Now to D. Question D. Copying that too. Let's bring it down to where we want to solve it. D. Total surface area. Total surface area. Total surface area. Total surface area equals 2 pi r into r plus h. And that's equal to 2 times 22 over 7 times the diameter here of a circular face is 2, so radius will be 1. And that's 2 times 22 over 7 times 1 into bracket radius, which is 1, plus length plus height, which is 3. And that means 2 times 2 is 20, is 44. That means 44 times 1 plus 3 is 4 times 1 is 1. 1 plus 3 is 4 times 1 is 4. 44 times, that's supposed to be 44. 44 times 4 over 7. And that's 25.143. 25.143. And that's approximately equal to 25.14 centimeters squared. That's to 2 decimal places. 25.14 centimeters squared. Now, let's take another example. Let's take another example. A cylinder, let's see what I'm going to do. Okay, let's take another example. Example 2. A cylinder of height a cylinder of height 12 centimeters and radius 5 centimeters is made of cardboard. Use the value 3.1 for pi. That means here pi is not 20/7, it's 3.1. Use the value 3.1 for pi to calculate the total area of cardboard. To calculate the total area of cardboard needed to make a closed cylinder, and B, a cylinder open at one end. That means we are finding the area of cardboard needed to make a closed cylinder and a cylinder open at one end, and the area also needed to make a cylinder open at one end. Now let's go to the solution. Area of cardboard. We are answering question A first. Area of cardboard. The area of cardboard which is needed. To make a closed cylinder is the same as the total surface area of the cylinder to be made. Area of cardboard equals 2 pi r squared plus, of course, 2 pi r h, which is the same as 2 pi r into r plus h. And that means 2 times, without forgetting that pi in this case is not 20/7 but 3.1. 2 pi r, that's 2 times 22, 2 times 3.1 times 5 into bracket 5 plus 12. I think I should write what was given before I go to let me write what was given. That's the formula, so let me write what was given. R radius is 5 centimeters, pi is 3.1, and height is 12 centimeters. So you can say therefore area of cardboard equals 2 pi r into r plus h, and that's the same as 2 times 3.1 times 5 into bracket 5 plus 12, and that's the same as 2 times 3.1 times 5 times 17, which is equal to 527 centimeters squared. Exactly. So when you're finding the air, it's just like the size of paper you need to form the cylinder. That's the same as the total surface area of the cylinder, because that paper is a net of the closed cylinder you want to form. And we have said that the net of the cylinder is actually a rectangle. So when you fold it, it folds into uh, it folds into three parts basically: the circular body of the cylinder and the two circular faces of it. So the net of a cylinder is actually a rectangle, and that's what we are seeing. That's what we can see here. Now B, what's the area of cardboard needed to make an open to make a cylinder open at one end? Here, surface area. In this case, the area of cardboard needed, the area here is going to be that of just one circular face plus the curved surface area, because the cylinder is open at one end. So area of cardboard, first of all, let's write what the surface area of an open cylinder is. The surface area of an open cylinder, surface area of an open cylinder is given by the formula pi r squared. We only consider the area of one circular face plus the curved surface area of the cylinder. That's pi r squared plus 2 pi r h. So therefore, the area of cardboard needed to make a cylinder open at one end, area of cardboard needed to make a cylinder open at one end, area of cardboard needed equals pi r squared into 2 pi r h. That's 3.1. I think I want to write it under it. Equals 3.1 times 5 times 5 plus 2 times 3.1 times 5 times h, which is 12, and that gives, and that's the same as 77.5 plus 372, and that's the same as 449.5 centimeters squared. So if you are to find the surface area of a cylinder open at one end, the formula is going to be pi r squared plus 2 pi r h, and not 2 pi r squared plus 2 pi r h, as in the previous examples. Now, so with that, I think we can take a very simple exercise. So you answer these questions. Number 1, calculate the curved, of course you have the formula for that, the curved surface area. Calculate the curved surface area of a cylinder the curved surface area of a cylindrical my spelling has to be correct, of a cylindrical container with the following dimensions. Take the value of pi, I'm sure. take the value of pi to be 3.14 most of the time. In fact, every time they give you what to use as pi. And the first cylinder has dimensions: radius 30 centimeters, height 36 centimeters, B, radius 15 centimeters, height radius 15 centimeters and height 1.2 centimeters. And C, diameter 58 centimeters and height 8.6 centimeters. Now number 2, question 2. A strip of paper. A strip of paper is wound 8 times. Is wound 8 times around a cylindrical. Is wound 8 times around a cylindrical pencil. A cylindrical pencil of diameter 7 millimeters. This might look a bit tricky, but it's simple. We use the value use the value 22/7 for pi. 22/7 for pi to find the length of the paper. To find the length of the paper, neglecting the thickness of the paper. You don't have to care about how thick the paper is. Neglect the thickness of the paper. Neglect the thickness of the paper. Neglect the thickness of the paper. So that's it, very, very simply. Please copy your notes neatly, write today's date, and do the exercise. I'll be waiting to receive your work for marking. Make sure your presentation is good, and I'll also make sure I mark and return to you. Thank you very much. See you in the next class. Bye bye.